And also, I haven't got a clue what I'm talking about. Other than that, sod it, let's start. So, Unit 7, as I hope you're all aware, is all about security of networks. There is a bit of networking in there, but it's not a whole lot. Essentially, you need to know that what a switch is, what an access point does, the basics of Wi-Fi security, that sort of thing. The main thing it focuses on, though, is how you can secure your network and the attacks and that sort of thing. Basically, 7.2 is a way is us creating defenses and preventing what we discussed in 7.1. So if you just use that and discuss how you can stop the things you've talked about, you'll be fine. So there's a big thing in it as well is user management. So there are two primary ways of doing user management, particularly in Windows. You have centralized, which is using an Active Directory. So you'll have one central domain controller server, and that will control everybody else's, and they'll all look up to that. These are very easy to manage once they're set up, but they're very hard to set up. They're getting much easier now we've got cloud technologies. You can set up an Azure Active Directory for very low cost, but businesses are still migrating over to this as it's a relatively new technology. Anything that's applied to the Active Directory can be rolled out to any computer in the network, but because you have to have those servers deployed and all of that sort of things, there's a very high setup cost. Also, the people who need to manage it, it's a bit more technical because it's legacy Windows stuff. So there's a medium maintenance cost in that sort of thing. Localized is when you are setting up a computer. You install Windows, you put all the settings you want on that computer, and then that's it. This is very, very hard to scale. Imagine if you've got 45 million computers in a network and you have to set up every single one individually and apply the same configuration. It's also very easy for them to go out of sync. So if an employee is to change the configuration, it's very hard for you to ensure and set it back without actually traveling over to that employee's computer, which in a multinational business could be particularly far away. But it's much nicer and it works much easier for the lower end. So if you've only got a few computers, it's very easy to set up. It's what most businesses and what every individual starts on. So it has a very low setup cost, but an incredibly high maintenance cost. This is only advised really for up to 5 to 10 computers. Now, the ways you can protect your computers in the network, because obviously everyone is trying to hack you. If you've got an Active Directory, you can push changes and configurations out using something called group policy. And this is essentially policies that go out to a specific group of people. Alongside, you can use a thing called SCCP. I can't actually remember what it's called now. Let me just Google it. Well, let's see. They've discontinued what I was talking about. It's now called Microsoft Intune, so that's another cloud thing. You can also use the advanced threat protections. This essentially takes everything that we're talking about and merges it into one big old bundle. Pretty much a buzzword for companies to use. These will often also come packaged with intrusion detection systems. Now, these do what they say in the tin. It's a system that detects intrusions. So if someone gets into your network, the idea of an IDS is that it detects it, tells you about it, and you can go and detect where they have broken in, essentially. Antiviruses is what absolutely everybody in the world is familiar with. These are your McAfee's, your semantics, your Malwarebytes, that sort of thing. These can be host-based or on the network. Network antiviruses are far less frequent these days, but you get sort of things like it will scan the network traffic as going through, but that's more of an ATP sort of thing. It does have that element of antivirus in there. It's scanning your traffic and it's preventing you from downloading a virus. But once it's on that endpoint, that computer, it has to be dealt with on the endpoint. You can also get firewalls. So every Windows computer has a firewall enabled by default. Interesting fact, every Mac computer has the firewall disabled by default because not a lot of things on Mac use ports, or not they don't use ports, but they don't have many open ports by default. These again could be over on the network or the host. So if you have a network firewall, it'll be choosing what can go in and out at the network level, and the host will obviously be at the host level. If you set a setting on your network firewall, a computer from outside your network can't go into your network, and if you set a setting on the host level, then a computer on your network can't talk to that computer on your network, if that made any sense there. Auditing essentially is logging. So someone does something, it puts it somewhere. This is a feature that you can enable in Windows. You can either have it on the host again, so it will just save it to a local file. This isn't the best idea, as it's very easy to manipulate the hard drive and change these logs. What's far better to do is if you set up auditing to send the audits to a central server, such as an Active Directory or some third-party products. As I've been saying, obviously, you can manage all of this through an Active Directory, which is always the best way to do it. You want all of your computers to have a uniform front. If you deploy an antivirus on each computer, it's likely you're going to miss something, something's going to break. If you do it on an Active Directory, you are pretty much guaranteed that every computer is going to have that antivirus. Oh, I've said about you can have firewalls only on the host if you do it localized, and IDS, you can install specific software packages locally, and auditing is local as well. Pretty much, if you do have over I cannot stress enough, if you have over 5 computers, you should not do anything locally. Everything should be done centralized. Restricting access. Now, the course we've got doesn't actually talk much about this because there's not a whole lot you can do in Windows. So the main thing they talk about is time restrictions. So Windows does a thing for this through Microsoft Family, and that's more designed to get children off their Xbox at the end of the day. But you can also get something through the actual group policy and the Active Directory side of things. You can limit it down so only certain users can log on at certain times. It's also very useful to restrict certain users to only being able to access certain computers. If they are accessing computers they're not to, you could also have it that if they were to access a computer they're not allowed to, they go into a honeypot environment, and that alerts a network admin so that you can almost fish the hacker into alerting you that they are there. Demilitarized zones. Now, these are quite a fun one. And the idea is that essentially you have your main network here. This will have your file servers, your computers, all of that sort of thing over here. And it's obviously going to be connected to your web servers and your server hosting and your public-facing thing. If someone can access this, traditionally, they'd be access to the whole thing. A demilitarized zone creates this edge barrier, a little pillow of web servers that can be accessed everywhere and without accessing your network. So this is very helpful to prevent people from essentially accessing stuff they shouldn't. You should never have services that should only be available on site, available to the public. There are certain companies that may do this that are particularly vulnerable to exploitation. Now, one of the most talked about things when we talk about security is how to detect viruses. There are 3 main approaches these days. You have the signature-based, so if you're in the TALAs, you'll remember this, but the signature-based, every single file has a specific signature. It's very complicated to do, but they go through an algorithm and they come out with a signature. There are these huge databases on the internet that have lists and lists and lists of these virus signatures, and you can scroll through these and see all the different viruses there are, or not the viruses, but the file types. So the idea is that they've got this list, they compare a file downloaded or a file running with this list, and if it matches the list, they quarantine them. Heuristic based, so heuristics is basically a fancy word for behaviors. What they'll do is they'll study a large group of viruses, they'll put them into servers and they'll run them and detect what sort of things they do. So for example, the WannaCry was constantly pinging out to a certain URL. That was a behavior of it, or a heuristic of the WannaCry virus, and said, whoever's just joined, if you could mute your mic, please. Yes, so the pinging of the URL was a heuristic or a behavior of the WannaCry virus, and that was going out to that server. So they sent that out to all of their antiviruses, and they detected that behavior. There's loads of different ones you can do. It can be copying files, it can be creating files, it could be certain different that sort of thing. And machine learning is a big black box that we don't actually know what it does, but we'll feed it's a bit of a combination of the two and some other fancy things that nobody really knows about. But we'll feed the viruses into the machine learning algorithm, they'll look at them, they'll work out what is going on, and they'll use that to predict what future viruses and what current undetected viruses will be doing. If it makes a match, using a risk-based algorithm, it will quarantine it as the other ones. Disaster recovery. This is one of my absolute favourite topics, mainly because everybody loves to talk about it, but nobody does it. So obviously, you should all be familiar with the rules of backups. 3, 2, 1, 3 copies of the data, 2 different... No, that's not right. Yes. Yeah, 3 copies of the data, 2 different storage mediums on 1 external site. So for example, I've got my laptop, which is the first. I just pull up a file every now and then. I've got a network-based hard drive in my house, and I have a load of files on OneDrive and Google Photos. So my three storage mediums are my laptop, my network-based storage, and my OneDrive. My 2 sites are my house. Sorry. Yeah, my 3 places are my OneDrive, laptop, network storage. My 2 storage mediums are hard drive and solid state, and my 1 different site is the external data center OneDrive. Sorry, I kind of just blacked that out to you. I'll send this PowerPoint along with the recording and a load of data to you guys later, and I'll leave some notes underneath so it actually makes sense instead of my just incoherent rambling. So, disaster recovery as well. Businesses, big businesses are making huge amounts of money, so they're going to want to reduce the amount of downtime as much as possible. For example, if you take a look at a site that's making £10,000 a minute, 15 minutes of downtime, that's £150,000. That's a lot of money to lose. So they'll invest lots and lots of money into creating disaster recovery protocols and procedures and that sort of thing. There are 3 primary sites or designs of sites that you're going to see when you are designing a disaster recovery program, or not program, but policy. So a cold site is cold. There are no servers, there are no computers. It's literally an empty building that they can ship servers and data into in the case of a catastrophic failure. These are the cheapest, but they are also the least useful, because there's that extended period of time where you've got to build up your network again. You've got to get all of your stuff running and that sort of thing. A warm site is you've got your servers there, you've got your data, you are ready to switch over. Essentially, you just have to turn it on. This is far more expensive to set up, but because your servers aren't running all the time, you don't have to pay that constant electricity bill, and it's much cheaper. A hot site is something that you'll use in a highly available situation. So most services will have one web server that serves all of your traffic. If that goes down, you've got to turn on your warm site and get that up and running. In a hot site, they have both on. They'll load balance between them. Half the traffic will go to the site A and half the traffic go to site B. If you look at things like Azure and AWS, these have got they've got hundreds of hot sites, and you can set up your databases and your web servers to run on a multitude of their sites. Hot sites are much, much cheaper to run in the cloud as well, because they're hosting all of the infrastructure. Now, I keep saying these are my favourite. I do just quite like doing security. It's a pretty fun topic to go over, but physical defences has got to be one of the best things to do, mainly because it involves breaking into stuff. So there's always 2 sides of the argument. You've got your companies and your big organisations who want to protect their data. They want to prevent anyone from getting in at all costs. Then on the other side, you've got your penetration testers, you've got your hackers, and you've just got general delinquents. So you've got to work out how you can prevent those penetration testers, hackers, and delinquents from getting into your building, your data, and potentially causing catastrophic data loss. So CCTV, obviously, this can be used as a proactive measure, but it's more reactive. Sorry, it can be used as a reactive measure, but it's more just protection. So typically, you would have CCTV in as many places as possible, and you'll either have a 24/7 crew watching the CCTV, which is where you can use it reactively, or it can be used for evidence gathering and helping out the police in their investigation. Biometrics, this can be anything from a fingerprint to your face to your iris, and according to Microsoft, your PIN. I don't personally think it is, but Microsoft pretty much defines tech these days. So you'd use biometric on the entrance gates as well as the server cages and all that sort of thing, anywhere you don't want someone to get into. Now, biometrics should never be used as a sole point of entry. More and more they are, but since they've been not discovered, but conceived of being used in computing, they've always been the advice that you should never use them exclusively. There should always be a additional measure, and biometrics should be used as a way of presenting yourself, not proving yourself. So, for example, if you have a fingerprint, you should provide a card as well with that, or a password or a PIN, something like that. There should always be at least 2 factors of entry. When you get to the higher levels, like in Azure's data centers, in the government data centers, you're going to end up having to do a card, a PIN, and a fingerprint, pretty much as many layers of authentication as possible. The final physical defense I'm going to talk about is data destruction. And you may be wondering why on earth you would want to destroy your own data. Surely that is going to be completely counterproductive. But you've got to think of it as if you are having complete secure. You've got to work out, is it going to be more expensive to pay the compensation out to customers if their data gets leaked, or is it going to be more expensive to recover that data? So not many companies do use data destruction, but in an emergency situation, but it is always to be considered. If you're going to spend £4 million in fines and fees, but you're going to spend £1 million recovering user addresses, then obviously you should go for the recovery of it. This isn't used anywhere near enough. Companies just don't want to destroy their data. They'd much rather just absorb or even not pay the fees. But these are all things to think about when you are doing your 7.2. You can also look into mobile device management. So companies will deploy an app onto mobile phones, and if that device gets lost or stolen, they'll immediately destroy the phone. It will get all that data wiped and it'll be useless. These can be used on laptops and personal devices. If you go in to find my iPhone, that's got an erase functionality. You can erase your phone remotely from that. And that is all I have got planned. So I'm just double checking my notes to see if I've missed anything. No, that should be all. So this is everything essentially in the textbook for 7.2. You're more than welcome to go and have a look as well. I'm going to be linking I'll put the PowerPoint in Teams and I'll put the recording up for you guys as well. Does anybody have any questions before I finish up here? Feel free to unmute yourself and put a question in the chat.
When looking at 7.2, Mr. Lewis, there wasn't actually a lot of, it was more physical. Will it actually be making a server?
A wonderful question there, Tom. So there are 2 ways of approaching it. You do actually have to produce something, so you have to do all of your planning, and then you actually have to build a network. So you'll either be using, I forgot the name of it, there's a piece of Cisco software where you can build a virtual network and do all that sort of thing and secure it that way. Or you can use the server apps we've got at school and actually build a proper network for yourselves. What is the actual task for 7.2? So 7.2, you need to plan and produce a network and then secure it. So I haven't got the brief in front of me, so I can't read it to you. But you're going to be planning a network deployment. You're going to have Wi-Fi, you're going to have switches, hopefully you're going to have firewall, all that sort of thing. And then you're going to have to secure it, and I believe either have yourself or another person attack it and see where your vulnerabilities lie. Matteo, please go ahead with your question. Yes, you can. We have, I say if anyone has got any more questions, please ask them now. Otherwise, I'm going to go ahead and conclude this lesson. Cool. I'm going to send out a Microsoft Teams assignment over Teams to Microsoft Forms assignment. Sorry, you're more than welcome to do it. If you don't want to, don't. But it's going to have a couple of questions of what we've gone over, a couple of long-ended questions, a couple of multiple choice, basically just to reinforce your knowledge a bit. Obviously, I can't force you to do anything, but I'd advise to give it a go, just so we've got some sort of information going into our brains. Other than that, thank you all for coming. I'll be doing a couple more of these over our wonderful quarantine.